Welcome to our video. Today we're gonna speak about processes. So what is a process? A process is a job or task. There can be many processes from a single program, such as Chrome could be executing many times on a given machine. However, the machine must represent each execution as a separate process.
Okay, so process, there are multiple process states. The few of them are such as shown in the diagram below. There's new, which is when a new process is created. Ready, when the process is waiting to be assigned to a processor. Run, when the instructions are being executed. Wait, when the process is waiting for a certain event to occur, such as getting an input, output, or a signal. And finally, there's the exit, when the program is terminated.
Okay, so for the process control block, it is stored inside a process table. The function of the process control block is it maintains information that the OS requires to manage a process. The PCB is updated whenever a change occurs for the process, such as a change in state or it is being terminated. Finally, the operating system will remove the process from the PCB as well as the operating table when the process is done and removed from the system.
So for a processor state, there are many states where it is made out of. Some of the states are actually regular counters, instruction counters, and even data registers. Other which are actually status registers and even stack pointers. An example of a processor state would actually be the minimum processor state and the maximum processor state. Next, we are going to speak about context switch. So what is a context switch? A context switch is a procedure that a computer CPU follows when it switches from a process to another. An example will be shown here. Starting here, we actually have process 1 with 3 CPU bursts. However, afterwards it is actually switched to process 2. This is actually what we call a context switch. So why is it important for a context switch then? Effective context switching is critical if a computer is to provide user-friendly multitasking. When the operating system switches between processors, it has a fair amount of processing of housekeeping to do.
Okay, to determine how effective a scheduling algorithm is, we have to look to the measures of performance. First is the throughput, which is the number of jobs that can be run at the same time. The average turnaround time is the start to the end of the job. The average response time is the amount of time from the submission to the end. The CPU utilization, which is the percentage of time running of a job. And finally, is the average wait time, which is the amount of time spent in the waiting the ready queue.
Okay, now we are gonna give you some example of process scheduling. Starting first, we will talk about first come first serve. As seen in the diagram, one example of first come first serve is actually a queue. The first to enter the queue would actually be the first to be utilized by the processor. So when the new process joins the queue, it will actually just go to the back of queue and wait for his turn.
So for the next process scheduling, we'll be talking about priority scheduling. The basic example is every process will be given a value to determine how high on the priority they are on. The one with the highest priority, which has the lowest value actually, will be going first, such as the VIP, skipping the line and going straight to the stop. For the next process scheduling algorithm, we'll be using the shortest runtime first. So the process with the shortest runtime will begin first, followed by the next. As shown in the diagram, process 4 only has 3 CPU bursts. Next is process 1, which is 6, process 3, which is 7, and process 2, which is 8.
Next, we are going to talk about shortest runtime first with preemptive. What is a preemptive? A preemptive is when a new process joins the queue and the system will actually check which process has the shortest runtime now. It will compare the one which just joined the queue and the current working process. For this example shown here, processor 1 will actually be the start as it arrives at time quantum 0. After one CPU burst though, processor 2 actually joined the queue, however it is only 4 bursts. Therefore, it will actually take priority and is being executed next. Once processor 2 is done executing, processor 4 will have already joined the queue and it actually has the lowest burst comparing to 1 and 3. Therefore, it will actually take priority and being executed. Lastly, processor 1 will be the next to execute, and it is only left with 7 bursts comparing to 9. And after processor 1 is done, processor 3 will then take priority. Next, we will actually talk about round robin, or some would actually call it first come first serve with preemptive. What it actually means is that when there is a time quantum, after every time, a specific amount of time, the processor has to stop and join back at the back of the queue, just like how first come first serve works. An example is shown here. Processor 1 is actually 24 bursts, whereas processor 2 and 3 is actually 3 bursts. Therefore, processor 1 will actually start from the time arrival 0, running up time of the time slice 4, which is meaning after 4 bursts, it will actually stop and moving on next with processor 2. Processor 2 will only run for 3 CPU bursts, stopping at time 7, and moving on next with processor 3, running up to 10. Afterwards, because there's no other new processor, they will actually move back to processor 1 to do the executing for every time slice all the way up to 30.
Okay, next we'll be talking about highest response ratio next. So the response ratio is given by this formula: waiting time plus burst time divided by burst time. This makes it such that the processes that have been in the waiting time gain higher priority compared to those that have just arrived. So for example, the formula has been calculated and has been given as shown in the numbers here. At time arrival equals 0, process 1 just arrived and there's no other processors waiting. So it is the highest response ratio and will finish first. Please note that it does not matter if you have a higher response ratio at any point, as it will wait until process 1 has finished its process before its execution before it runs next. Finally, we'll be talking about multi-level feedback queue next. The way this algorithm works is it separates processes into multiple queues, and they are allowed to move between each queue. They are separated due to the number of CPU bursts each of the processors require. So for example, and you will switch between queues as it goes down the CPU burst. The queue with the highest priority will be the one with the lowest burst time in general, and as if it's going on for too long, it will go to a lower queue, and as such it will prevent starvation.